Planes. How do we write the equation of a plane? Remember how we write the equation of a line in 2 dimensions? We had a few methods. We had slope-intercept form. We had standard form. We had point-slope form. And I believe we had another form which was general form, ax plus by plus c equals 0, and that c is not the same thing as this c. The standard form of a plane in space is closely related to point-slope form. It's a times x minus x1 plus b times y minus y1 plus c times z minus z1 equals 0, where a comma b comma c, so those coefficients are the x, y, and z components of a normal vector. So normal, remember normal means perpendicular or orthogonal. And x1, y1, z1 is a point on the plane. So if I have a plane, I'm looking for a perpendicular vector, and saying that perpendicular vector has components a, b, and c, and then a random point on the plane, we use those as our x1, y1, z1. If we want to write it in general form, we can also write it with ax plus by plus c, z equals d equals 0, and that's just by multiplying this out and combining like terms. Notice that this a, b, and c are still going to be the same a, b, and c for a normal vector. So essentially what we're saying is the coefficients will be a normal vector, a perpendicular vector to the plane. So write the component form of a vector perpendicular to this. Looks confusing, but the big idea is that the perpendicular vector is just given by the coefficients. -9, 3, 12 is a perpendicular vector to this plane. Write the equation of a plane through this point and perpendicular to this vector. So the formula says we use the vector as the coefficients, and x minus x1, y minus y1, z minus z1 are going to be using the point. So x minus 4, y plus 6, z minus 9. This will work as the equation of our plane. It's a little weird, but all you need to know is that these coefficients match up with a perpendicular vector, an orthogonal or normal vector, and these values represent the point any random point that it goes through.